Okay, can you hear me? I hope you all can hear me. My name is Fabian Basciani, and I am going to talk about testing, especially important in your DevOps transformation journey is to keep your quality high. Let me introduce myself. So my name is Fabian Basciani. I'm a technical lead. I'm working on the equity trading desk at JP Morgan Asset Management in London. And as most of you, we are on a huge DevOps transformation journey. And here I will present a couple of lessons and design patterns that we started using, and they worked quite well for us. About JP Morgan, JP Morgan is very big company. We have around 250,000 employees worldwide. Around 50,000 of them are technologists, and we spend around $11 billion a year on technology. So a lot of technology going on at JP Morgan. Some more information about what we do. I'm specifically in the equity trading desk. We trade around 1% of equities traded globally. We trade nearly all securities, nearly all the markets globally. What I'm trying to say here, a lot of volume, a lot of money involved. So we care a lot about quality. Especially interesting is automation. So what we do is we have a lot of fully automated trading in place. And what I want to highlight here is basically the interaction of a fully automated system, like a robot, that actually has to interact with a human. And again, here is important that if you have such a system, that you still can evolve quickly, but you don't want to break things. So I was here. By the way, I guess you all know the movie Matrix. I love the movie. So yeah, about DevOps, many times we talk about the speed of delivery, incremental change, multiple times we deploy. You are not on mute. Someone is not on mute. So one thing I guess most of you are familiar with is the testing pyramid. It was introduced by Mike Cohen in his book Succeeding with Agile. And on a high level, it's simple. We got the unit tests at the bottom. They are fast, but they're very isolated. And the higher up you go, closer to UI testing, you do actually full integration. But these are fragile tests. They are very, very slow. Now, this is a pyramid. If things go wrong, in the past, I have seen many projects ending up like that basically you had a tiny layer of unit tests, and then the developer would just throw it over the fence, the software, and leave it to the testing team, and the testing team would create a massive end-to-end, fully integrated test suite, and a lot of people would be employed just to look after that, right? Then over time, people took testing more seriously, and most people ended up in a healthy pyramid, what I would call, where you have around 70% of unit testing, 20% of integration testing, and just a thin layer on top where you do the fully integrated UI, middleware to backend, and full thing. Now I think we evolved, and we need to slice the testing pyramid even further, especially the integration part. What I mean by this is, as I have it here in gray, is splitting up by component, integration, and API. There are even more layers, but I think these are the three key ones, because if we run some tests, and for example, we would do a REST call, and you do every single time, let's say for each test scenario, and you have, let's say, 20 scenarios, and you make 20 REST calls, you also every single time test the API. But there is in a sense, that's not very efficient. That's actually very expensive. You need to fire up a server or at least mock it, stub it, and you would actually test the API to the same thing multiple times. So there is no point in doing that. So if you, for example, go into component testing, where you, and here the buzzword is microservices, especially where you have separate microservices, and then you just say, okay, I want to test the behavior of that one microservice, and for now I ignore how I expose some endpoints and so on. I just want to make sure this can be tested independently of the API. You should be able to do that. And yeah, another thing that we pay a lot of attention is the whole shift left. So we had software developers, of course, business analysts, project manager, QA people, and so on. And over the last years, I would say 4 to 5 years, where we jumped on this DevOps transformation journey, we tried very, very hard to shift things left. So this also means that we today do not have a QA team anymore. We don't have dedicated project managers. We don't have business analysts. We have, in that sense, technologists, and all the technologists are coding. Today, I think we are around 90% of people write code in our department. This means a developer would do the requirements engineering. A developer would obviously develop the software, write the unit tests, component tests. Then we would do the user acceptance testing, doing the integration testing, but also we do the production support where possible. Especially interesting is that it gives you, as a developer, a sense of ownership if you're responsible for the whole thing. Again, if there is a microservice, you look after the microservice from requirements gathering into production, and you are responsible for the whole life cycle of that microservice. Key benefits that I see for the shift left is no handovers. So you don't need to pass it on to a BA, the BA to a dev, and so on, which is much more efficient and also less error prone, like misunderstandings. We can get rid of this. Also, if the developer is responsible also for testing, he is or she is incentivized to actually automate that. Another thing that we do see is that each app should be able to tested and be run locally. This is very powerful. So you don't need to merge back into the trunk or master or release branch, whatever you have. A developer can build something, run it local, testing locally, not affect anyone. That's very powerful. Another thing that we try hard is that we try to minimize the dependencies on third-party systems. I mean, we have third-party systems, but we try to minimize the dependency with stuff like anti-corruption layers. And another key thing, especially for quality assurance, is that we are not dependent on specific test data in a test environment or in a UAT environment. So basically, you should be able to create any test scenario at any point in time and not rely on a third-party system or specific test. But the one thing, key point, I think, is the collaboration. So we have this cross-functional teams. Some people are better in the business know-how, some are better in the hardcore nitty-gritty tech stuff, others are better in managing things, project management. And the key is that we all sit on the same table and work together on the same thing or for the same goal or product. And how we do that, for example, is that we set developer, the quants, these are quantitative people who analyze trading behavior. We all sit next to each other. So even though we are, in a sense, from the org chart in different divisions, we actually sit next to each other. We call this co-location, and we found that extremely powerful to accelerate business deliveries. One thing about automation, I like this meme give here. Some people say fake it till you make it. I guess I disagree. Obviously, if we need to take automation seriously and do it properly. So now we come to event sourcing. So we had all those shift left component testing in mind, and what we found is event sourcing leads very, very nicely into those things. Martin Fowler, actually in general, Martin Fowler has a fantastic blog, so I highly recommend checking out the blog from Martin Fowler. He already talked about event sourcing 10, 15 years ago, and event sourcing on a very high level is as simple as that anything that changes the state of your app is an event. So anything gets injected as an event, and yes, and another thing, sorry, that I want to stress here is also that you then go completely asynchronous, especially in microservices where you have a lot to do with request and response. We go completely asynchronous because anything like say a request or a response is an event, and thus we need to capture it. So now we always think of action and reaction like in the physical world, right? That they come together, and we feel very natural. So here, if this little human here jumps forward, actually the boat will go backwards. That's very intuitive for us because it is manifested in the physical world. But in software, it doesn't have to be like that. So it's in a sense counterintuitive. What I mean by this is today most people think, I make a request, I get a response, and the request. In that little point here in the middle, this is where then I handle the request and I handle the response. If you go proper async and if you go into the event sourcing, those things do not need to come together like this. They look more like that. That actually there is just a continuous flow of events entering your system like an event stream, and you need in your app via a state machine understand the sequence of the events and what they mean. So if I have a request event, you are now in pending processing something, and once you receive another event, you know, oh, this transaction is now complete. So in our very simple REST call, if you have microservices, a lot of people use REST call for microservices, you trigger a request event to get some data, and later you get a response event which gives you that specific data, and now finally the transaction is complete. Here I have a high level overview architecture of such a system. So on the left hand side, I call this external data from external systems, and these can be many different systems, different ways of getting it, Kafka, JMS, REST responses, whatever you have in your world. And we internalize them into events. So in my world, we have like orders. So an order becomes an order event. So we internalize them into an event and we put them onto a dispatcher here. And the dispatcher then knows about for each event which processor it belongs to. So if I have an order coming in, the order event goes into an order processor, has the business logic to handle that order event. Now, let's say I have this order event and need to ship it, or we call it release it, then I need to make another REST call to another system. To do that, we have this so-called external processor. So this is the yellow swim lane here. There, we do not have any business logic. These are just mechanical things to handle those requests. So I have, excuse me, an event coming in. It's the request event for to ship, request shipping event, or request release event. Then we offload it because we go now asynchronous to a different thread pool, which then communicates to whatever system you have, is an IO event or distributed cache database or another REST server, whatever it is. And once, and that's the key point, if you now receive the feedback from a REST call or whatsoever you read from the database and you get the result back, you do not process it straight away here. You actually, via this executor, it will create, guess what, an event saying like, here is your data event, and injects it as external. So this is now in the middle here, basically dispatch it is a spinning loop, just processing non-stop your events. So what does this mean for quality assurance and testing? This means that actually anything is just a chronological order event stream of data. So any data comes from external and you can just inject it as an event. Anything that you consume, you have to make sure you internalize it into your internal representation of a data structure. So if you have, in my example, orders coming in, I do not inject that order data from the external. I map it into my own internal representation. This means later when I do testing, I have my own way of representing any scenario. And we have to make sure that anything is async, which means that request and response, in a sense, are completely detached from each other. So now I want to do component testing, and a good way to do this is BDD, so behavior driven development. So I just say I have given some events, and then another event arrives, which then should result in event Y to be executed. In my order example, we have given some order comes in, then shipping event arrives. We should see that we trigger the shipping event. Another key point here is that if you have exceptions or negative scenarios, they are not special at all. They are just behavior. They are just events. You make a REST call, and the REST call might time out. It's simply REST call times out event, which goes again into a processor which handles that scenario. So here is a code snippet where I do this. So I have order. Let's keep in mind here, actually, order means an order to trade on the market. I come from the financial background, so equity trading. So I simply say, okay, I receive one order. So this is basically the given part. Given is the first order arrives, the second order arrives, and now, based on that, I would expect that the last event is I request something, which means a REST call would have been made. So now expand this. So I say, okay, I have the strategy request would have been made, this request event would have been made. So as we remember, we go completely async, which means I go back here. Once I do the REST call, the result will be re-injected and be just another event coming in. I here have now the result. We call this now strategy selection success event. So it's a success event. Think of it as the response event here. And as I have my own representation of the data, I can now just use whatever data I want. And I can, for example, see, did we later trigger a release request or a ship event? So I give you here an example where I run this in my IDE. And here I combine now, I do not check against the request event. I use now the state machine for this. So we can see here the lines, state, and I check for each step, is it in the right state? Pending means an action is happening. So a REST call was made or a write to a database. And I can just inject those events. Here's success event. So I got the success back. You see here, I have many events because we're black box testing. So in reality, there are many events and processing happen, but I just inject the external events. The internal ones, I don't need to do. They are just triggered internally. And here we try to release it now, and I fake actually, oh, order timeout. What would have happened? So I can simply say, and the timeout happened. I do not need to stop a REST a server which then times out or fake it somehow. No, I can inject and just see how does my app behave if I have a time. This is a different topic. As you can see, in sports, often if something controversial happens or too many things happen at the same time or it happens very, very quickly, we need replays. So here we have a replay where we try to find out, was it a foul or not? Is it a dive or not? Is it a penalty or not? And by the way, do you think it was a penalty? I don't think so, to be honest. But so what we do is we replay, right? So imagine now you have a production incident. In trading, we receive market updates in milliseconds, from milli to microseconds, and a lot of stuff is going on. And obviously, we can't log everything because the log would just explode, and anyway, no one would be able to read it anymore because way too much stuff is happening. So now the beauty is, because everything is an external event coming in and it is chronologically ordered event stream, we actually can persist that chronological event stream. And if something happens, let's say in production, I can go grab that log and replay that log and locally can reproduce exactly the same scenario that happened in production, because the state of the app is created by those external events coming in. By replaying them, I have exactly the same state as before. So this is super powerful if you have very complex business logic. A lot of things are happening at the same time, and yes, and you need to be able to reproduce it. So no more, oh, let me add some more logging because I cannot reproduce what actually happened. Here, any scenario can be replayed and reproduced. I give you an example of here. So we had an issue where we blew up a tiny bit of text, but the key point here is I do order ID. So now I put a breakpoint where this blows up. I put a conditional breakpoint, say like, okay, give me stop here, please, once this order ID arrives. Then I go now investigate everything. So the caches are populated because it recreated the whole state. So I have exactly the same as it was in production. So let's have a look. Oh, we see 285 instruments, 234 orders were actually in there. So, okay, let's investigate further because we have the state machine. So is something going on in the state machine? What state was this order in? Let's have a look. State. So the state is pending. So we were actually performing an action. We were actually canceling a release. Okay. And now I can investigate further and further. This was actually a very complicated case because that order didn't work because it relied on many other orders. And because I have now the cache and all the orders in cache, I can actually reproduce quite nicely the whole scenario and could reproduce this complicated scenario. So yes, so this is behavior-driven testing using event sourcing, and I hope yeah, you enjoyed it. I'm happy to answer any questions. Are there any questions from the audience? If not, then I think yeah, that's it from me. Thank you very much for attending, and yeah, best of luck with your DevOps transformation journey. Take care, everyone, and yeah, stay at home, stay inside to save life. Take care, everyone. Thank you.